I can't let you in. There'll be a field to put it in. They won't let you in downstairs. It's just like they're upping security because of all the terrorism in Europe and stuff. So I can't really argue with that. And I think that's about it. It just will be closing the signups around noon the same day as the event, which kind of sucks. I like it like today everyone's able to sign up at the last minute or just come or bring someone. I don't really have an option unless we find a new place beyond that. So, but other than that, I'll just let Alfonso start.
Okay.
Sounds good. Thanks for coming.
So, as Rick says, thanks a lot for coming. It's my first time in New York, my first time presenting Rick's groups. I want to say thanks a lot to him for giving me this opportunity. Thanks a lot for you. Thanks a lot to you for showing interest and coming here for the break. You'll have to excuse my English, okay? Sorry. So I may struggle a bit with some long sentences, but yeah, I'll try. We have some slides and code, so you can hopefully you can follow the talk. Okay, so we are here to talk about Fable tonight. Fable is a compiler from F# code to JavaScript code, and I'm going to try to reply these 3 questions. So, what is the Fable? Why you should consider using it, and how does Fable work, and how you can use it. So, but first, let's start with the who, and who is making the presentation. That's me, that's Alfonso Garcia-Caro. I have a degree in linguistics, so no computer science. So also, again, that you have to excuse if I say something that is not very clever, programming-wise. I was living in Japan and Germany. I'm from Spain, and I'm also living in Spain now, in my hometown, in Madrid. I have around 4 years of programming .NET experience, because as I said, I was working before as a translator, and then I taught myself programming, and it's more or less the time I've been programming. But 2 years ago, I discovered F#, and also I started to do some web programming, so I was looking for a way to mix both of them. It was programming TypeScript, which was a previous project to compile to JavaScript, and now I've developed Fable. So hopefully you like it, and hopefully it makes JavaScript a true backend for F#. I've developed desktop, mobile, and web applications for the video game, the green energy, and the education industries. My current company is Toggle.com. We do the product which has the same name, which is a very simple time tracking application that you can use if you have to build clients and you have to try to track your time. It's a tool that's intended not to take up your time, to measure your time. So yeah, if you want to give it a try, it's Toggle.com. It's free to download. And also my company has been kind enough to give me some goodies for you. Wow. So if you want, at the end of the talk, you can take one of them.
So you must have gotten funding.
Sorry?
I said, figured you all got funding.
Yeah. It's a lot of fun. Yeah, it's a very cool company. So let's start with the what. What's Fable? Sorry. Fable is we already said that it's an F# to JavaScript compiler, which has some interesting features, like using source maps for debugging, so you can debug directly the F# code. There is also a plugin system. This means that you can adapt the compilation to your needs. It's not a closed environment. It's also framework agnostic. This means that you don't have to compromise with any UI, JavaScript library or something like that to use Fable. You can use Fable with any library, framework, or any pattern you want to use. And it also comes with better chart, so it's you can use most of the F# core library, and also you can use some of the .NET base class library classes, like datetime, regular expressions, or dictionaries, hashes, such. One important thing of Fable is that it's not using an ad hoc language, because as you know, there are this program JavaScript is ubiquitous. It's used for many things, mainly for the browser. but it has some limitations, and some companies have tried to overcome the limitation by creating a new language. Okay, so creating a new language has the benefits of that you can create the semantics, so it has no friction with JavaScript. It's, as you probably know, how JavaScript has a lot of quirks, and it's very difficult to target from currently existing language. But this is not the case of F#. F# is a general purpose language, and this means that when you use Fable, you don't have to learn new semantics, or you don't have to use new tooling, and you don't have to learn new API. Sorry, can you see it well here? It's semantics, tooling, and APIs. But I think this strong point of Fable that even if it's not an ad hoc language, it behaves like one. It means that it's not you are not just compiling your code and creating a bubble to run your code in the browser or in a Node application. No, it means that you can use your code to interact with JavaScript in a very seamless way. So you don't have any runtime. Okay, so there is a very tiny core library, around 30 kilobytes in MD5. But it's compiled into very clean JavaScript code, and also it has a very great interoperability with other JavaScript libraries. And very important, because now in JavaScript you have a lot of very cool development tools, and this means that with Fable you can use them. You can use Babel, you can use NPM, and or Webpack, for example. And why you should use this? As I just said, that JavaScript now has very cool development tools, and also it had limitations, but now with ECMAScript 2015, you have new features like classes, modules, so the need to use another language seems not to be happening anymore. But there are still some things that we programmers, especially .NET programmers, miss, like static typing or great editor support out of the box, or a comprehensive core library. So, for example, in JavaScript now we have linters, and we have things to improve our workflow, but it's very difficult to configure them. So in this case, I know probably you use Visual Studio, and when you use Visual Studio you get spoiled because you are used to have a lot of features right after opening the IDE. Okay? And with Fable and F# you can do this. You can do this and also a couple of more features, which I'm not going to spend much time explaining this, because I think most of you already program or know F#, right? So, as you know, we have in F#, we have the REPL, IntelliSense, type inference, custom operators, parent matching. So all of these, you can use it on when targeting JavaScript if you use Fable. We still have more features. In the F# core library, we have observables, we have string formatting, structural comparison, iterables, list comprehensions, unions, the records, the tuples, the type aliases, the DSLs embedded in the language. We have async. We have also object-oriented programming techniques like inheritance, interfaces, abstract classes, for example, that they are not there yet for JavaScript. We have custom computation expressions, overloading, type routers. They are coming to Fable. They are not available at the moment, but we do have units of measure, compiler directives, and also this. I think it's very important that if we use functional programming, we have the perfect excuse to be condescending to other non-functional programmers. And also, if you do anything with F#, you notice that those time, if you tweet about this, those time will retweet it. So I think it's a very important feature of using F#. But there is also one more. There is a killer feature, which is other reports. Okay. So I think you know that 2 weeks ago there was a guy that had an NPM package called leftpad, which was 11 lines of code, and he decided to retry the package from NPM, and he broke the internet. Okay, because everybody was depending on that. So with Fable, you have leftpad, you have rightpad, you have string formatting, the .NET string formatting, and also the F# type string formatting. Okay, can you see it? Can you see it well? You see this here. You have the results. So you will like this. So you can use start left, you can use stop right. You can choose the character. So this is a little example of all the things that you can do if you use directly the F# core library. And I want to talk a bit about how does Fable work, because Fable is working like as a normal compiler, and a normal compiler is doing. They do a very complicated job, but actually the way they do it is very simple. They only have 3 steps. So first step is parsing and validating your source code. Then they build an AST, an abstract syntax tree from there. And they, with this AST, they make some transformation. Usually they do they do optimizations on, or they have to do maybe another kind of transformations. That the target is to generate new code, which can be assembly code, which can be bytecode for .NET or the JVM, or in this case, can be another kind of code like JavaScript. So the advantage of using Fable and using array existing languages is that we can use existing tools. In this case, the F# compiler is like Roslyn, so it's exposing an API, it's a services that we can use. This means that we already have the first step for free. So this first step, that is parsing and validating, Fable doesn't need to worry about it. The F# compiler is doing it automatically. But JS is not a compiled language, okay? So this is not possible in JS, or is it? So let's enter Babel, which is, do you know Babel? Do you work with JavaScript from the applications? So Babel, as you know, this we have now ECMAScript 2015, but this doesn't mean that all the browsers already implemented everything. So with Babel, we can implement, we can convert the new features of JavaScript to old or ES5 JavaScript, so they can be run in every browser. So this means that we have now 2 pipelines. There is F# compiler, which is generating the AST to create to generate IL, and Babel, which is taking modern JavaScript and making also an AST and generating JavaScript code. This means that Fable can step in and reuse this work, okay? So we can focus on this part. Okay, so the parsing and validation is done for us, and also generating JavaScript code is done for us. This is very good because Fable can stand on the giant shoulders, sorry. And we don't have, we can target different, we can target ECMAScript 6, we can target ES5 easily without doing anything because Babel is already doing it for us. But why do we need this AST? So Fable is also doing some optimizations and is doing a call replacement. This is how the how we can use the F# core library directly in JavaScript code, and also the plugin system is also using this internal AST. But there's a more important how. This how, it's okay to know how Fable works, but we actually want to know how we can use Fable. Okay, so Fable, very important, is just an npm package you can download from npm. So I can show you. It's here in npm, and to install, just need to do, if you have Node and npm on your machine, just have to do npm install. I usually do it with a global modifier, so I can run the Fable command from anywhere. Okay, you need to remember that the name of the package is Fable compiler because Fable was already taken, so I couldn't use it. So, but the command is Fable. So this will be a very simple Hello World application that we can use directly from scratch. That simply we just need to, I can show it to you. We just need to create a directory. In this case, I think I already have it. Okay. We can go to the directory. We can very simple hello world fsharp script file. Now we can run it. I'm on a Mac right now, so I'm using this fsharp I. If you have Windows, it will be fsi. We have this. Sorry. Yeah. Okay, so we have this very simple script. Let's try to compile it to JavaScript using Fable. Okay, so the compilation has started. We have the file compiled, and then we can run this with Node. Okay, now we have this hello.js, this hello world. Okay.
Can you cut the file?
Sorry.
Can you show the file? Show the hello.js file.
Okay. Yeah, of course. Okay. As you can see, it's a very simple code. What you see here, it's actually a model system, because if you know, JavaScript has different model systems before they were standardized with ECMAScript 6. By default, if you don't say anything, it will compile to UMD models, which are compatible, universally compatible with Node and the browser. But in this case, if we are only going to run this with Node, we can say, okay, I only want common.js models. And you see here that now the code is much simpler. And in this case, we are calling the Babel core library. Again, install it. Sorry, because I already have it installed here. I already had it here. But the compiler is already calling automatically the Fable core library for us, and in this case, this doing the F# formatting. We don't have anything, but we could do something like, let's say, hello world. Okay. And it will be the same. Now we have this. We can run it with no normal. Okay, so that was very simple. I've shown you the module option here, but we have several more to compile to tailor the compilation to our needs. So we can say where do we want to put the generated JavaScript files, if we want to use source map or not. We want to say the version, the JavaScript version we want to target. We can use symbols for compilation, like a debug or release, something like that. We can use plugins for Fable. We can use plugins for Babel. We can have reference to other projects, like we normally do with Visual Studio Solutions, for example. This one is to compile byte arrays, and we can have also different targets for compilation. We'll see this in a while, in a moment. As you can see, this can get a bit complicated if you have several options and you have to type them all the time. So we are also supporting the Fable config JSON file. This is very similar. I don't know if you have worked with TypeScript. In TypeScript, we also have TypeScript tsconfig JSON, I think. So this is very similar. It's just the same options that we use with the command line. We can specify them in a Fable config JSON, and there are also some extra ones like scripts. So we can run special scripts at the beginning or at the end of the build process. Right now we have only pre-build and post-build, but there will be more events coming. And you can see here that we have, so for example, when we are targeting debug, we can have some extra or override the default options. Let's see a demo, a bit simple, but a bit more complete demo for a console application. This one is here. It's in the project. You have it in samples, Node, console. You have it here. So you can take it at home if you want. So in this case, you can see we have a FS spray. We have in this here only a single file. No, actually we have two. Okay, we have our very simple library here in a subfolder, and we have this with an entry point with arguments. Okay, and we are going to use this argument to make something like a hello world, but just reverting the argument. So we are using a Fable configuration file here, and we are specifying the project file. So in this case, we don't even need to tell Fable where is the project file to compile. We can go there. Just type in Fable. It will automatically detect the Fable configuration file in the same directory. Sorry, compilation. And because we are saying, okay, when we finish the compilation, you have to run the code. We have it here. We can say hello. Hello, New York. I have it reversed. Okay. So very, very simple application, but as you can see, there are already very interesting things happening here. First, all the references, because in JavaScript the modules have to reference to each other. So all these references are done automatically for us. We go. You're seeing here that we are keeping the same file structure, but the references to other files are being done automatically. Then we have the entry point, okay? And we have the argument. So this is translated to Node code automatically for us as well. And we also have source maps here. Okay, so we have a very, very simple, even if we have a very, very simple application, we want to test it, okay? Because we are very good developers, so we test everything. And we are going to write a test for our very simple application, which is like this. That we are just going to use nyc, which is the standard test runner for .NET, and write a test like this, okay? Here we have some Philly because we have the talk at Philly as well. But we could use New York. Yeah, wait, please.
How did those references work? Do you have like a unit JavaScript file somewhere that it automatically swaps out?
This working with no. In this case, this working with we are not going to run this in JavaScript with a translation of any unit. We are going to run it with Mocha, which is a very common test runner for JavaScript. And what we have to do is translate this test to something that Mocha understands. Okay. We are going to do this with a plugin. So to compile here, you see that we are just calling our test file, and we are going to use this plugin, which is a plugin that is already built to translate any unit test, to Mocha test. So let's try it. We have here as you can see, we can say, hello. Yeah. folder. We already have this plugin build. If you want to test it, you have to run first the build of the whole project. So. Okay, so we have it here. Okay, you can see. And here we have the test. If you know Mocha, this is how the Mocha test look like. Okay, so we're using it, and then we are passing the function. And as you can see, the name of the test is becoming the name of the function is becoming the name of the test. Let's try it with. I have Mocha installed here. Okay, so as you can see, not very fancy, but we can see that our test is passing. If we decide to, if we do something wrong, maybe, yeah, do it the same. You can repeat it again, compile, try it, and it's working now.
JavaScript works.
Oh, wait.
So the
No. So, sorry,
wrong file.
it's I'll put in this. Okay, sorry. I have to- It's here, sorry. I'm putting in the wrong directory. Okay, so you can see here that our test is not. Okay. You have to forgive me on that. No, okay. No, I was putting the result in the wrong directory. Okay, so now you can see that the test is failed. And Fable itself, it's doing this, it's using this method. And the good thing about this is that you can run the code, the test, and if you want to run them in .NET, you can use any unit, and when you want to run them in JavaScript, you can use Mocha. Okay, so this is important if you want to create a cross-platform application that, let's say that you are using an application for .NET, but you want to distribute, and because most people, there are many more developers that are using NPM than .NET at the moment, so maybe you want to distribute using NPM, okay? So this will be a way to do it. But these two examples we have seen, we have used the F# code library, which is very cool, but we know that out there in NPM and there are many JavaScript projects and tools that are very cool, and we want to use them. We want to use all of them, okay? Because .NET, yeah.
So I guess the F# code was never compiled itself, right, into CLR. So if there was like a syntax error on that, where would that be?
Yeah. If we make a syntax error, it will be because it's we are not compiling the code to .NET to IEL, okay? but we are building the AST. And if the code is, if there is a syntax error, the F-sharp compiler will complain. We can check very quickly. So for example, if we do something like this, let's put an integer is firing here. Now if we try to compile, it's going to complain. Okay. So it's telling me there's an error.
What is
See?
AST?
AST?
Yes, what is it?
Abstract syntax tree. It means that you take the, it's better to use to see it visually, but it means that you get the all the expressions and you build like a tree with them. Okay, and this is very useful when you are manipulating everything. And especially this very useful and easy to use in F-sharp because you have better matching. Okay, and you have also active pattern, so it's really easy to just manipulate and recognize everything using these active patterns and pattern matching. And also because in pattern matching you have in F-sharp is comprehensive. It means that you can just check the entire AST because the number of possibilities, the number of expressions is actually limited. Okay, so there is only a number of expressions that you can use in the language. So we were saying that the Net community is great, the F-sharp community is fantastic, but the JavaScript community is huge. Okay, the JavaScript community is really big. I don't know if you notice that you work with both of them, and just looking at the numbers in GitHub, you have an extra project, and you only have a number of stars, and then you go to the JavaScript project, and you get thousands of stars and users. I'm really envious of that. But the thing is that if we want to go to JavaScript, we want to also, we don't want to be only a guest. We want to be a participant and being able to use all the tools. The JavaScript community is also amazing, by the way. Okay, it's not that I'm saying that it's huge. I'm not gonna. We have several methods, to interact with JavaScript. The first one is dynamic programming because JavaScript is a dynamic language, so we are not going to try to interact statically all the time with it. Sometimes we need to get the job done, and in this case, we can just interact dynamically, even if we don't have static checking, which is a pity, but at least we can interact quickly with JavaScript. So we have, can you see it well from there? We have the question mark, which is the standard operator in F-sharp for dynamic programming. This is in the Fable core module. We have also assignment. We can, with this, we cannot use something directly as a function. But we have now Fable core is implementing the dollar operator, as in Haskell, to make applications. Okay, so we can use it like this. And if we need to use the new keyword in JavaScript, we can use this create new. And we can also do create object to create JavaScript literal objects. Okay, so this for your convenience, this operator. But if you want to use some different operators, you can just overload them. Okay, and give it a different name. We can also emit directly JavaScript macros. So if we need, in the case we need to put just JavaScript code directly in our F-sharp code, we can use the emit attribute. I don't know if you ever used FunScript. There was a similar feature. In JavaScript you had emit inline and normal emit. In this case, we are using always inline emit. So this is very simple. It's just it's using like a Scala that you can use the dollar and the number of the index of the parameter. We can just also use an indefinite number of parameters. And in this case, for example, if we want to implement get and set, we can also use conditional syntax. But the most interesting feature is using foreign interfaces, because in this case we can use static checking. So this is the best way to bring the best of the two worlds. So we can use the JavaScript libraries, but at the same time we can have static typing, we can have auto completion, and everything is much more simpler for us. So in this case, it's very easy. For example, if you want to use this module from Node, we can just define an abstract interface, and we are going to use the import attribute to import the modules into our code, the same way as we use in ECMAScript 6. I don't know if you know, but you can have a look here on in the documentation of Mozilla Development Network. It's more or less it's translated like this. So if you want to import a namespace, you use the star. If you want to import only a member, you do it like this. And if you want to import the default member, you do it like this as well. So in the Fable core package, you already have interfaces, these interfaces for native JavaScript methods, like JSON parse, for example. You have also for the browser APIs and for Node. Okay, you can have more definitions in the Fable import packages. Have a look here. We don't have that many at the moment, but the idea is to put many of them there. And you can generate your own foreign interfaces using TypeScript to Fable parser. Okay, it's still in development because the TypeScript also TypeScript has is evolving and is adding features every time, so it's a bit difficult to parse all the definition files, and also TypeScript has a complicated type system that is not always possible to map one by one to F#, but we have something that we can use to semi-automatically generate this automatic interface. We generate the bulk of the code, and then we can edit it by hand. So let's with this, let's take a demo to create a Node static server. So again, this is also in the GitHub repository. Here. Someone is dancing.
Yeah, I guess so. There, a school just opened up there.
That's good. It's good. I come from Spain, and we dance flamenco there, so I'm very used to this sound. We call it zapateado. Okay, so it's like a
Yeah, but her timing's a mess.
Sorry?
Her timing is a mess.
Okay, so as you can see here, we are just importing in this case we are just using, because we only have one file, we are just using a JavaScript file, we don't need a project file. And then we are importing the Fable core, DLL, which contains the front-end interfaces. And we can import, we can open the JS model, the browser model, or in this case, we are going to use the Node model. We have require that we can invoke to invoke Node libraries. We have a process here to access the arguments or the current directory, for example, the environment variables. So we can use auto-completion normally here. And also, if we make a misspelling, the F# compiler will warn us. So in this case here, we have the foreign interfaces for the Node models, the Node core models, but serve static is an external library, and we only want to use it directly with the directory where we want to serve the files from, and we don't need a foreign interface for that. So we are just going to use dynamic programming, just applying with the $operator. You can also write it like this. Okay, it will be the same. same for final handler, we are doing the same, just passing the request and the response to it directly. And with this, we already have a very simple Node static server. Okay, we are not going to, we can compile it, but we are not going to use it just yet, because we are going to use it when we are creating a front-end application. Again, we have the Fable config JSON, so we don't have to say anything else. Okay, this is compiled. So we'll check it out later. Now we are going to see another server, but in this case with a very simple REST API. And for that, we are going to use Express. Do you know Express? It's a very popular server in Node because the bare bones Node only is good to even not a static server, because we had to use external libraries. But Express is a very standard way in the Node community to create REST API. Sorry, and we are going to debug this using Visual Studio Code, which is capable to debug visual Node applications. For that, we need a launch JSON file, which is here. The JSON file is automatically generated when you go to debug tab. You press this icon, your icon. It will be generated automatically for you. So you just need to tell it. In this case, we can pass directly our F# file, okay? And then we'll say where are the generated JavaScript files, and let's say also to Visual Studio Code to use source maps. So you can see it here. We are running this with Node, and we are just launching the application. So we have the application again here in Express. This is also a very simple F# script file, and in this case we do have foreign interfaces for Express. So just invoke it. We have app, we have the get verb, set, no, not set, sorry, post, or put, for example. So we have the normal HTTP verbs. And here we're going to define a URL with an argument, name in this case.
Interesting.
Yeah.
What's the type of app?
It's in this case it will be just Express. It's an interface defined in the Express definition file. You can just go there, and you'll see that invoke return this interface, and this interface like this. This is an item for application, and you have all these methods. So these interfaces are empty because the real methods are implemented in JavaScript. Okay. This is more or less a direct translation to TypeScript definition files. Do you know them? That you have also files to generate the IntelliSense when you are working with TypeScript. So we can use this to generate these files also. So again, let's try to compile everything. That's with the Fable command. And in this case, we are not going to run it with Node. We are going to run it with directly with Visual Studio Code, as you saw here. We have this launch, and before launching, we are going to set here a breakpoint. So you can see that this is running with Node. And we have a local server. We say York, and we have hit our breakpoint. We can check everything directly from our F-sharp code. We can have the debug console, in this case only with JavaScript, sorry. But no. But, okay, so you can check that it's not working because it's directly dynamic, but we can say in the debug console. And then if we let it run, so we have our hello New York here. So this happening thanks to the source maps. You see here that the source map is being generated for us. Okay, so developing Node applications is nice. It's nice to have the possibility to create a console application targeting both .NET and Node. But the main reason to compile to JavaScript is to create front-end applications. Okay, because in Node we have Node. We can like it or not. It's very very useful also. But the real thing, the place where we can only use JavaScript and nothing else is the browser, okay? So this is the main reason to compile to JavaScript. And we are going to make two very simple front-end applications, and to demonstrate that it's not, we don't depend on any specific framework, we are going to use two of them, okay? In this case, Vue, I don't know if you know it, it's a very simple UI framework for JavaScript. It's a bit similar to Angular in the sense that you can use string templates. And also we have React. That is the cool thing nowadays for the front-end world, that you put most of your template code directly in your JavaScript code, okay? So let's have a look. First we do browser. This is going to be a to-do MVC application. As you can see, this is our HTML. We have the template here with the special Vue syntax. And then in this case, we are not going to use any we are not going to use any tool like Webpack to bundle everything. We are just going to load everything directly to memory with it's from HTML. Okay, so as you can see here, these are our dependencies. And then we are going to use, because this is MD, which is asynchronous mode loading for JavaScript, we are going to use require.js to load everything. So we just need to tell require.js where to find the Fable core library, and then we can start our application, which will be called index.js. This is our code. You can see we are going to use to create the application under 200 lines of code, and because we are accessing the methods, the objects globally, we are just going to use the global attribute, and we are going to interact. So for example, this is going to be our router library. We are going to interact with it completely dynamically. Okay, so we have create new. We have the dynamic operators. So this code is actually, if you see the original JavaScript code, is just translated literally. So in the case, you have to check Stack Overflow, and you have to check some JavaScript code, and you don't need to do anything different. You can just put the code directly into F-sharp, just change the operators, and it will work fine. So the interesting thing of this, we have the very simple middle layer, which is this, the Vue helper, is the Vue library, and it's allowing us to use a view model, okay, a type view model. This is not very functional because, as you can see, everything is mutable, so it's just translation, very simple, from the JavaScript example, but it's showing that we can use type. For example, these are also mutable, but a very simple model to do. And we have, so you can see here, we have the static typing. We can, if we make a mistake, the compiler will tell us. If we try to pass something that is not the correct type, the compiler will tell us as well. So let's check it. Let's go to the browser. Again, just Fable, typing Fable is enough. Compilation has started. We have our file, and now is when we are going to use the static server we compiled for. So let's call it from this directory. Now, server. Okay, so we have our server running. Here. Okay, so we have here our to-dos. Okay, so we have travel to New York, which is already completed, and talk about Babel. We are in train of completing it right now. We have the filters. Okay, so if we say active, we only get the active views, and if we say New York, if we say completed, we get the completed to-dos. Good? Any questions so far? Yeah.
I have one question. It might be kind of dumb, mostly coming from a position of ignorance. But like, why would you want to compile F# to Node? Like, what's the benefit?
Yeah, I think the main benefits that you can distribute your application to many more users. So, for example, if you're having a command line interface for something, I think hopefully, let's see if .NET Core has a success and many developers have installed. But the chances that Mac users, for example, they have Node installed is much higher than .NET. So I think this is a benefit. And then you also have some tools that are very easy to use in Node, and maybe you want to use them. So I don't know, maybe the server, you can do this directly from .NET, but maybe you want to use Express or something like that. So for example, Fable itself is using a library Node to parse the command line arguments. That's very useful to use, and I didn't find anything similar in .NET. So it didn't fit my needs. But in this case, I could use using Node. So. Sorry, you were.
Yeah, just to piggyback on that is that sometimes if you want to get the entire .NET framework into a space, I mean that's a certain kind of commitment. Whereas if you're running Node, Node will run in almost anywhere with almost no overhead. So just from an overhead standpoint, you could see some benefit.
Hopefully, they say that now .NET Core is lighter and more performant than Node, but we still have to see that. So.
How light? I mean, how many? What's the smallest instance you could run?
Oh no, I know. I didn't try myself. So
I mean, does anybody know what the smallest .NET instance you can slot into at a remote server?
20 or 30 megabytes?
Yeah, I think it's about 30 megabytes because it's
As
going
an
to be a little
executable?
bit bigger than the old Silverlight. If you remember, Silverlight was
Oh
like,
God, what a piece!
well, but you don't know the plugin was like 20 to 30 megabyte. Pretty much going to be a little bit bigger than that.
So about 20 to 30 as an executable.
Yeah.
Right, so you could, yeah.
For the environment.
Which in some cases is way smaller than Node.js installed package.
Yeah, well, you're about the same. You're about the same.
And also, sorry, very quickly, one very important thing of comparing to Node is that there are also very cool things now with Node. You can use Electron to create desktop applications, and also you may want to use. Right now, it's still using FunScript, but you know the Ion IDE, which is the plugin to use F# with Visual Studio Code or with Atom, is done with FunScript as well. So we are also hoping to convert this to Fable. So it's useful that you can use all the node methods from there as well. So sorry, yeah.
Yeah, so I guess two things when we're talking about using, like Fable for more server-side type things. One, I guess I know we said we can use BCL, but can we use things like thread pool in?
No. It's
Okay.
VCL. The VCL, the part of the VCL you can use is very simple. It's mostly the methods that are already in JavaScript, but you want to use the .NET APIs. So, for example, for regular expressions, you can use them in JavaScript, but you need to remember the APIs for JavaScript. And for me, in my case, for example, I'm always confusing them, and to get the groups and everything is a pain. So.
Yeah, that's just what I was thinking of. Any kind of conflicts with like the more kind of single-threaded node model versus how things would be done in like F# programs. And then the second thing is just around, I guess, floating point precision with kind of .NET.
Yeah, right now it's compiling because one of the guidelines of Fable was to compile directly to a very clean JavaScript code. So even if this means sacrificing a bit of the semantics, so right now every number is compiled directly to just a number in JavaScript, which I think is more or less a float in 64 bits float will be in .NET. I think for most of the JavaScript built virtual machines, so it will be like that. Except for the type arrays. So if you're using an int array, this will be compiled directly to the type 32-bit integer array in JavaScript. So you get the performance benefit of using type arrays, especially when working, for example, with web canvas.
I have a question. How do you convert the F# AST to the Babel AST, because they're different language, right?
Yeah, but you can just I just transform the key is this picture. This is one of the very good advantages of using. This is the main advantage of using Babel, because with Babel I can convert the AST from F# to an AST that Babel understands, and then I just handle it to Babel, and Babel will generate the JavaScript code for me.
You mean Babel take the JSON, the AST of JSON? Okay.
Correct. It takes a JSON and it just translates to JavaScript.
Is that stable, or they're changing like the?
We currently have over 600 unit tests, and they are all passing.
I mean, if the Babel they change the format, then you have to adapt your.
Yeah. Of course, if Babel does something, but Babel is very extended in JavaScript community, and there are many tools already depending on it. So it's they cannot just do anything with the code, because there are many people depending on it, and it will hurt Fable, but it will hurt many other people.
So by calling a Fable, you are running the AST, and then you are calling the Babel, yes?
Yes.
Okay.
It's like this. So we have, just to show it very quickly, we have this, okay? This one is taken from Babel documentation. I just took this and generate the types from there, and I'm just translating everything to these types, and then generating a JSON, and I send it to Babel, and Babel takes care of compiling everything to TypeScript.
Do you have some sample JSON?
Sorry?
JSON, a very minimal example of the JSON?
You can see if you want. We can, but it's not nice. It's not. I can show it to you, but it will be very. I have to. Maybe. Just because it's not predefined, so I think maybe it's better if you check. this file here, the specs of Babel, is telling you the entire AST that Babel is using. So you can have a look here, and this more or less is very JSON parsable. So it's something like this. So this is what we are targeting. Okay. Yeah, sorry, Rick.
It's okay. I was wondering, like, are there any other spots that you didn't mention in F# that don't currently work? Like, do quotations work?
No, quotations are not working.
Or, like, probably not reflection?
Yeah, that's one of the things, because, for example, TypeScript, it was using a very clever technique to use to allow reflection for generic. We are erasing generics in the compiled code, and yeah, it's a balance you have to have, because TypeScript was compiling every method according to generic. So this was good because you had the generic information at runtime, but it means that you have to compile every method to the specific type. So it means, for example, that you couldn't share the Fable core library, the core library in the case of TypeScript. So in this case, I think it's better that you can share the library, and yeah, even if you lose some information. But you have interfaces, okay? The interfaces are there, so you can, so for example here, in the documentation, you can, there is a very cool pattern by Yanku, the burning monk, to overcome the expression problem in F# to use interfaces with unit types. Okay, and this pattern can be used with Fable, because Fable understands you can use pattern matching with interfaces. Okay, and another thing is that you can use sometimes you can use generics with inline methods. If you mark a method as inline, it will be inline in the generated code, and in this case you can use, for example, you can write type of T, something like that.
So you can use statically resolved type parameters.
Yeah, something like that. Okay, I didn't explore not yet the type providers in Fable, but they should work also with core replacement or with plugins. So
it does seem like it would be hard to get the type provider support without the quotations.
No, I don't think so. In TypeScript, the type providers were working just by, because at the end you get I need to check, but at the end you get what you get from the F# compiler is just the sugar code. Okay, so you don't get all the stuff that the developer is looking at in the IDE. So then you get these methods, and then you just replace them, and it should be fine. Because, for example, the JSON provider is very easy to implement, because it's just the only thing, the important thing is that it's giving to you the methods in real time, but then in the runtime you just access them dynamically, and you are done. So I don't see. I still need to explore, and I still need to create some samples with type providers, but I don't see. Maybe I'm wrong, but I think that it's going to be very difficult to implement them. Are we okay?
Sounds good.
So we have this.